So hi, my name is Anton. I work for IBM. I'm the chief architect for IBM Cloud Application Identity Service. Right. A couple of words about what I do. Right. To set context. We're based here in Austin. By the way, I'm local, very local. So for a change, I don't need to fly to a conference. We're creating a service that will allow developers to easily add authentication, authorization, access control capabilities into their applications. Right. Obviously, we're talking about cloud applications that are built in cloud. I will be talking a lot about cloud, right? And I'm coming from IBM. I will not be talking about IBM Cloud. All the concepts I'm going to be covering today, they are generic. They apply to any cloud. That's the reason for multi-cloud in the presentation topic. Okay. So the service I provide, basically, we store personal data, PII, of millions of users, okay, for our customers. You probably understand the responsibility we have, right? And we make sure that data is secured, right? That data is protected, encrypted, not hackable, right? And everything basically that we need. That's the sleep well at night part, right? So you need to understand the responsibility, and you need to do whatever you need to do in order to cope with that. So I'm coming from IBM, so we have to have some legal disclaimers, obviously, right? Basically, you don't have to read this. The idea is this is not a legal advice session. This is basically me sharing our experience, right? And giving some best practices that we use, and you're welcome to adopt everything. So cloud. I work in cloud for about 6 or 7 years. I work in security field of cloud for about, I would say, 4 years. Okay, strictly dedicated to security. And whoops. Where did it? Is it missing a slide? Oh, there it is. Okay. And cloud is definitely an opportunity to do security right. Okay. So you probably heard about, hey, we cannot put our applications to cloud. Cloud is not secure, right? So this kind of more of a conservative approach, has its reasons, but cloud is definitely an opportunity to make your applications more secured, right? And you just need to know how to do that. So things we're going to cover today, we're going to talk a little bit about security breaches, right? So in order to understand how to do the security the right way, you kind of need to look at the ways how security works not in the right way. Security risks and shared responsibility model, how to secure your cloud workloads, the model that we're following, DevSecOps. Probably everyone heard about DevOps. We go with DevSecOps model. And then different capabilities that you might want to leverage when you're building your cloud applications. Threat protection, identity and access, data protection, visibility, some advice and action items, and we'll end with Q&A. So let's start with this, right? If you go to Wikipedia, okay, you'll see, and search for data breaches, you'll see this. Most breaches occur in North America. Estimated that average cost of a data breach will be over 150 million by 2020. Right, in 2019, only collection of 2.7 billion identity records consisted of blah, 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 emails, blah, 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 passwords was posted on the web for sale. So those numbers are, well, not very encouraging, right? Those numbers mean that, yes, security is important, and you definitely need to take it seriously. To give you a few examples, right? Anyone here ever ordered food from DoorDash? Has a Facebook profile, used Quest Diagnostics for blood works, used Truecaller application, their Android device. I don't think they have it for iOS. Or play Texas Hold'em using Zynga online, right? All of them were hacked. You probably heard about these breaches, like Capital One recently, 100 million Capital One customers, credit card applications were breached. Equifax, I think everyone heard about that. British Airways faces 230 million fine after it was compromised for personal details of half a million, right, customers. You definitely do not want to have your name here in this list as well. Those are the companies, right, who had data breaches this year. Probably everyone heard about Equifax. Not everyone heard about all of these, right? You can take it beyond that, right? If you ever flew Air Canada or Cathay Pacific, if you play Bethesda software games, right? If you ever use Google Plus, ever stayed at Marriott, posted to Quora or Reddit, used WordPress. Anyone here ever used United States Postal Service? Right? 2018, right? Hacked 2018, and that's roughly 20% of US population. Okay? So security breaches is not something you should take. This is data from Wikipedia, by the way. Right? It's not something you should take lightly, right? This is really, really serious, and you need to consider that when you're building your applications. Now, I cannot say that security capabilities of those companies are not good. No, I mean, we have Facebook here. Google, they're probably the best in this field, right? They do everything there is, right, to protect their application. It wouldn't be fair to say that any one of these guys have bad security. No, they probably have the best ever security people and best ever security capabilities. But everyone got their weak spot, okay? And all it takes is to find that weak spot. If I recall correctly, Equifax breach was due to unpatched open source library, right? So basically, they used some open source library that was pretty old. They wanted to patch it, but they kind of forgot about it. As a result, well, you all know the result, right? 150 million social security numbers, etc. So there are different factors when you're taking your application to cloud that increase exposure to security risks, right? So first of all, you need to understand that you're taking your application to cloud, you're exposing public APIs. Yes, we're going to be talking about authorization, etc., but your stuff goes to public cloud. More APIs you expose, more entry points into your ecosystem you provide. More applications you put on public cloud, well, those are public now, but guess what? End users, they're not always inside of your VPN or, they want those applications to be public, right? More third-party integrations you do, right? More security vulnerabilities you might experience. Now it's not just your responsibility for your stuff, but now it's your responsibility for all the third parties that you use. And attackers, they're becoming smarter, right? They're actually becoming smarter, they're learning. They're no longer just using their own computers. Right now they're creating botnets, right? Networks of devices trying to hack or DDoS your ecosystem. And it's not even computers anymore. Those could be mobile devices or some IoT devices, Raspberry Pis, etc. So attackers are becoming smarter as well. And government and media, they're not really helping. I mean, they're doing their job, right? But they're introducing tons of new policies, right? So now, instead of focusing on your business value, you need to be compliant with tons of different policies. And media, every time there is a breach, it will be published, it will be, they will rip you to pieces, basically, okay? So this is not really helping, but because of all that, customers and users, they became much more aware of those things, right? So if 10 years ago, some public service was breached and data was stolen, probably no one would ever hear about it. And users, they have no idea what that even means. Today, people know this, right? And they will come to you asking questions. So most cloud providers provide what we call a shared responsibility model, right? So if you go to IBM, Amazon, Microsoft, it doesn't really matter which cloud provider you choose, right? The responsibility for security is shared. So the provider is responsible for their stuff, for what's happening on the cloud. So if they're providing some kind of a mechanism for provision virtual machines, they are responsible for security of those virtual machines. If they're providing a Kubernetes service, they're responsible for security of that Kubernetes service. But basically stuff on the cloud. But it's you who are building applications that run on that cloud. And it doesn't really matter how secure that virtual machine or container ecosystem is. If you decided to store passwords in clear text in a public database with root/root access credentials, there's absolutely nothing cloud provider can do about it, right? And if you haven't read the details about Capital One breach, I highly recommend reading about it. It was all about permissions and API keys that had access to the stuff they shouldn't have access, okay? So while cloud providers are responsible for security of the cloud, You're responsible for security of your applications. So how to secure your cloud workloads, right? First of all, you're building your applications, how to make them secure. Every single cloud provider provides tools for that, right? And they provide recommendations. Recommendations-wise, let's see what we have, right? The approach we recommend is called Developer Security and Operation, DevSecOps. Everyone is familiar with DevOps. That's where you combine development and operations. Why? Well, because in cloud, it's really hard not to work this way, to work in a more legacy model where your development is fully decoupled from your operations. Your developers have no idea why your application misbehaves in cloud, right? Your operators, they cannot patch anything. They have to go to development team in order to help them. So DevOps model exists for, I would say, about at least 5-6 years, right? And it really helped, at least it really helped us to improve the way we operate in cloud. However, you cannot really decouple security, right, from operations and from development. Your operations have to be secured, right? Basic things like, access to your production environments, right? That's operations. Basic things in your application, do not store passwords in clear text, right? So that's purely operation thing. So both developers and operators and DevOps people, they need to think about security. We call this DevSecOps model. Okay, it works great for us, right? It's not easy to start with, right? It's not like, hey, we're gonna start tomorrow, okay? It takes time and education to achieve that. But again, just to remind you, the service that we're building contains personal data of millions of users all around the globe, okay? We just cannot afford going the other way. So I'll quickly go through following slides and you'll get this deck at the end anyway, right? Because those slides they have a lot of content, okay? So, this is the standard approach for DevOps, right? You start with designing, you develop and build, you test your stuff, you deploy it, you maintain. Obviously, the whole process is based on iterations. It's not waterfall one by one, right? Someone is deploying, someone is building at the same time, and you learn at each phase, right? So that's kind of a timeline, a life cycle of application that you build. Each one of those phases, right, think about security. What's going on in each one of those phases? So this is not just how many users are using my application, right? So everyone heard about use cases. Anyone here heard about abuse cases? So that's a very, very interesting term, right? Well, it's not brand new, but it's rather, well, it's younger than use case, that's for sure. The idea is use case, how can users successfully use your application, right, with benefit for a user? Abuse case, how can attacker use your application with a benefit for attacker? How can he perform harmful action on your application? So going into each one of those phases a little bit more detailed. Everything starts with people and culture, right? If you're not telling your developers, right, or being a developer yourself, if you're not considering those security risks from day one, from day zero, right, you need to change that. I'm not saying you need to read all the, the Bible of encryption or whatever, right? But OWASP, top 10 vulnerabilities, you have to know them, right? Most common breaches, you have to know them. You need to understand where, how attackers are, what technologies they're using to attack your application. In the design phase, when architects and developers are working for design, think about threat modeling. So you're building a new module. How can this module be breached, right? What can the attacker do in order to retrieve data there? Do some risk analysis, right? Let's say this component is breached. What happens next? What's the term we use is blast radius, right? Let's say someone managed to get access to one of the microservices in your ecosystem. What's next? If your whole ecosystem, like 20 microservices, communicate over plain HTTP, that basically means they can sniff all the traffic within your cluster or whatever you use ecosystem. If you use HTTPS, even inside of your cluster, there's no such option, right? They breach one microservice, that's it. They cannot go beyond that sniffing traffic because it's all encrypted. Security backlog. Treat security items with top priority, okay? You do not want to be in news, right? Not being in news, that's a good way to go, right? No one wants to be in news, say, with 500,000 user records stolen, et cetera, et cetera. So build, develop, test, deploy. That's more of a technical phases, right? I will not elaborate here too much. Basically, in application development, do not store passwords in clear text, right? Avoid SQL injections, right? So those are basic development stuff, but it's not, it's not obvious for everyone, right? So emphasize, right, and make sure your teams are aware of those issues, right? We do a lot of brown bag sessions, basically every Friday, roughly a day from today, right? We gather with lunches and we talk about some new security exposure or security threat model, et cetera, et cetera. So we're making sure that it's part of our, DNA, right? Making sure our stuff is secure. Infrastructure and build. Use build tools, right? If you build your microservices, you might need to deploy them at some point. In order to deploy them, you need to have some kind of credentials to that environment, right? So those credentials needs to be stored securely, right? Obviously. In the test phase, we do compliance check. Without going too deep into compliance, right? You might want to test for things like, if you're familiar with SOC controls, FedRAMP, right? Basically, there are tools that allow you to test your microservices against those policies, right? So if you want to make sure that your services, your applications are continuously compliant. Deploy, application orchestration, infrastructure orchestration. You can use virtual machines in cloud. Lately, it's much more popular to use containers. Obviously, all those systems, they come with their own security rules. So make sure, you're considering that when you're doing your deployments. Maintain. That's one of the most critical parts because you can build secure application, right? The most secure application unhackable up to that date in the world, deploy it, right? But, 2 weeks from that day, a new security vulnerability was discovered in one of the million open source libraries that you use. How do you know about it? Okay, and if you're not monitoring for that, if you're not doing any maintenance on the stuff that is already deployed, you do not know. Okay, that's pretty much what happened roughly what happened at Equifax. So make sure you use tools to visualize, right, your ecosystem. Right? If you're building Kubernetes-based applications, there are tools like Istio Service Mesh and different other tools that help you to visualize your ecosystem, your microservices and communications between them. So you can, without reading gigabytes of logs, literally see, hey, this guy is talking to this guy, they shouldn't be talking. Okay, this guy for some reason is serving a 700 megabyte zip file. That's not normal, right? These are the things that you need to detect. And I'll go into tools later as well. Detect, contain, stabilize. So a little bit more into design phase, right? You're welcome to take a picture of this slide or you'll get those slides anyway afterwards. Things like, validate your threat models and experiment. So we have hack days. Basically, the idea is we gather, right, the whole team, right, several dozen people, we gather, and the goal is not to create, new features. The goal is to hack the hell out of our systems, right? And we actually give prizes for that, right? So, our developers are basically trying to hack stuff that other developers implemented to see what are the possible threat models that we can detect. Analyze risk, right? Privacy by design. Never store sensitive data in clear text, right? Every single database you have in cloud today supports encryption. We're going to be talking about soon. Data protection, protect your data. What happens if your data is stolen? Okay, so if you do proper encryption with proper encryption key management, it's not a big deal. Yeah, data is stolen, but it's not really accessible. So technically, I can do a database dump of the databases that we use internally in our identity service, put it on public internet, and there's absolutely no one in this world who can do anything with that, right? Because it's fully encrypted. We have 3 layers of data encryption, okay? So what happens, if your data is stolen? Is it end of the world or, well, minor inconvenience? How do you treat and obviously do analyze your risks, see, prioritize this one is more important, this one is less important. Security backlog. So this is coming from the maintain phase, obviously, right? Whenever you detect stuff, you put them in your security backlog. That's where you start to discover those abuse cases, use cases, abuse cases. Treat them seriously, right? There is always some kind of a feature that customer is asking for, and that's probably more important from business priorities perspective, right? So who's here on the technical side? Less on the business side, but more on the technical side. Okay, most. Who's here more on the business side? Okay, I apologize. Okay, so treat security backlog, with top priority, because yes, there's always business requirements and there's always not enough resources to implement everything, but do not take security lightly, right? You do not want to be on that Wikipedia page. Uh, Yeah, that's pretty much the same. Okay. Right. So in the develop, build, test, deploy phase, that's basically where your development happens. Okay. Since you already told your developers, we have a strategy for making sure our application is secure, right? We do risk and compliance alignment. We have, basically we're teaching our developers about security. We're having workshops explaining, how to deal with security. So people and culture, that's crucial. But then you have the bottom line, you have some kind of a registry of your containers, of your application. You have a source code repository, right? And you have some kind of an image repository, depending whether you're using virtual machines or containers or whatever. That's pretty much the output of your development part, right? Some source code and images that you're gonna run in environments. Test all of those, right? So if you're building container registry, inspect the configuration of those containers, right? Does your container really need root access, right? And in many cases, developers are going to use that, well, because it's easier, right? But do they really need root access to the host machine? Probably not, right? Test for SAST, IST, IST, right? Security acceptance testing, et cetera, Introduce those tests as part of your build process, okay? So it's not just unit test failed, okay, so we need to fail the build because tests are not passing. Introduce security into the same workflow. Right, so do some minor version of penetration test during your build process. Okay, make sure you don't have any security regression issues. Okay, and that again aligns with that DevSecOps model, right? So security is part of development; it's part of the operations. Test for common abuse cases. You can get a list of common abuse cases from the internet. You can have a list, built based on your own experience. So test those use cases. Do not ignore them. Right, compliance, that's a different thing. Source code. A lot of vulnerabilities are originating from, old open source libraries being used, right? So there are tons of tools. A lot of them are free, right? That will actually check your code for older version of open sources, for vulnerable version of open sources, and they will tell you, hey, you need to patch that ASAP, right? We have that. Every other major cloud provider have that. There are tons of open sources tools that you can just use, right? And it's a very simple thing. It's a command line tool that you integrate in your CI/CD pipeline, and basically it's saving you from a possible breach in future. Okay. So let's go forward, right? At the end, at the maintain phase, right, you need to visualize, right, basically all those issues. You need to detect them, right? And that's continuous container scanning, vulnerability scanning. You need to monitor your configurations. That was the problem with Capital One breach, right? Basically, they had a bad misconfiguration, right? Web application firewall. That I will go into each one of these in my following slide, right? So web application firewall, that's basically something that can help you to detect someone is trying to hack you, right? Contain those problems, so do not ignore them, obviously. Respond, report, if you need to revert or update some configuration, just do it, right? Or patching. And perform root cause analysis. So this thing, root cause analysis, we've introduced this in our development processes, I would say about 2 years ago. This helped us enormously. There are books written on root cause analysis. Even though it sounds like a very simple concept, there are literally books written on it. And I highly recommend reading about how to do a proper root cause analysis. So the most sensitive part there is not to look for who's guilty, right? Because you always try to, okay, what if, right? No one cares what if, someone would have done something differently, right? No one cares about, what could have happened. This is what happened. Let's understand how this happened, what was the reason, right? Not who was guilty and who was responsible. No one cares, right? What was the reason, and let's see how can we address that reason. So root cause analysis, we started with, we had the RCA meetings for about 5-6 hours, right? Right now we're roughly at 15 minutes per RCA meeting. It's much more efficient. It helps us enormously. Okay. So let's look what the secure cloud application looks like, okay? So it has several layers. Obviously, I'm clustering things here. So basically, you start with managing access. You need to detect whether access to that application should be granted, right? So whether maybe someone is trying to DDoS you, right, or sending too many requests with different passwords, brute forcing, right? So network threat protection, then you have identity and access layer. That's where you detect who the user is. That's where you authenticate the incoming request and check whether that request is authorized to do the stuff that it is trying to do, right? Then you need to protect your data, right? I mean, you can just store that data in clear text in database. It would work, but that's not the most secure way to protect your data, right? That's probably the worst way to protect your data. How do you protect your data at rest, right? Well, in transit, that's HTTPS. That's the baseline, right? How do you protect your data at rest? How do you manage your encryption keys? How do you protect your data while it's being used by a particular computer? So, data in database is encrypted. Data on the wire is HTTPS, so also encrypted. But in order for your application to process the data, it needs to be decrypted, right? So how do you protect that, right? That segment. What if someone hacks into your virtual machine or host or whatever and just does a memory dump, okay, and gets everything in clear text? And at the end, you need to gain visibility, right? If something bad is happening, you need to know about it, right? Because you cannot react on something you do not know. You need to have some kind of audit of activity logs, some kind of management for your certificates, right? You're using TLS certificates, you're using different kinds of certificates for different kinds of things, and you need to have some kind of a dashboard that shows you what's your security posture. Every major cloud provider has that, okay? And all of that is provided on top of the secure platform. So let's go through these layers one by one. Network threat protection. Anyone here using Akamai, Cloudflare, AWS CloudFront? Okay, so there are tons of services like that, right? Classic or legacy firewalls, I mean, they still work, right? But they're not covering all the scenarios you want to cover in cloud, right? Cloud applications are different, okay? By the way, if anyone tells you that building application in cloud is incredibly easy, no, it's not. They're lying to you, okay? It's much easier, right, comparing to on-prem, but it's not easy, okay? So things you are looking for in network threat protection, things like, well, basic things like DDoS protection, right? What if someone is trying to send you 50 billion requests a second from multiple sources across the globe, right? And your application just simply cannot handle that because it was not built for that, right? So that's a denial of service, distributed denial of service. You want to make sure that the threat protection layer you use can handle that. Web application firewall. So this is a relatively new thing, right? Relatively comparing to DDoS, right? It works on a higher level. Essentially, it's a firewall, right? But it's designed for web applications. So it's not strictly looking at the layer 3 and 4, right? It's looking a little bit on a higher level. It's more inspecting HTTP layer, right? Looking at things like someone is trying to do some injection, for example, SQL injection. The request body contains information that not looks suspicious, that is structured suspiciously, right? Someone is sending you 50 lines of JavaScript, right, in request body that it's supposed to receive, name or something like that. So that's the web application firewall. TLS, do not ignore TLS, older TLS. Prior to TLS, we had SSL. Older versions are not considered secured anymore. Always use the most recent TLS. As of today, 1.2 is good enough, but we're slowly moving to 1.3, right? It's not fully finalized yet, but the industry is slowly moving there. Okay, rate limiting. DDoS protection will protect you from distributed denial of service, but what if you know that your microservices, you have a particular capacity. You do not want to scale endlessly. Why? Well, because it's expensive. Okay, you cannot just auto scale until you run out of money. You want to limit that capability, right? So let's say you want to serve at most 1,000 requests per second. Okay, that's your goal, right? Anything beyond that, you consider that as being too much request for your capacity. Or on the other hand, the service that you're selling, right? You sell it based on the capacity. So you're charging $1 per request for first 100 requests per second, right? $2 for the next 100 requests. So basically rate limiting for requests. That's also a capability that you want to have in your network threat protection solution. DNS and GLB, that's two concepts that exist for quite some time, right? DNS server. Today you have DNS servers who are actually secured, right? So IBM got one, Amazon got one. There are also Cloudflare, right? They have their own secure DNS. Basically, it's a DNS server that will not resolve DNS if the resulting website is considered offensive or malicious. Okay, basically it will just reject DNS resolution. Global load balancers can help you to quickly route traffic across your deployment. So if you have, for example, 3 clusters in different regions connected through one global load balancer, and one of them becomes unstable, compromised, or whatever, it takes time to solve that. But what you can do quickly, and quickly I mean a couple of seconds, you can go to global load balancer and just disconnect that cluster. So your users, they're not affected. You have a security breach in 33% of your ecosystem, right? But you're handling that, that's fine. You just quickly, in a matter of a few seconds, you disconnect it from the production environment, right? Your capacity is lower, but at least the information is not exposed. So those are bottom, they're more performance features, they're less security features. But obviously you can have caching solutions, right? Page rules, meaning if a request is sent to a particular URL, I want to inject some headers, right? And smart routing, the goal of those solutions is to make sure that users will get the content they're requesting as soon as possible. Usually all of those solutions, Akamai, Cloudflare, the ones that AWS provides, right? They're working in a similar way. You put a component, right, between your users and your servers. Okay, and the first question when I'm showing the slide usually, but doesn't it make it slower, right? Well, no, it actually makes it faster. Okay, because those solutions, they are designed to optimize traffic. Okay, yeah, for some requests, right, it might add like additional 5 milliseconds, something like that. But for most requests, they will optimize the traffic, and moreover, cached information will basically it will sit much closer to the user. Right? So if you're hosting your application in the US and you have users somewhere in Asia Pacific, they will not need to go to US to download that, right? They will get content from some cached local cached version. So moving to the next layer, identity and access. So let's say your network threat protection did not detect any suspicious network activity. Request is in your ecosystem. Now you need to understand who that request is coming from, right? And whether it's authorized. Every cloud provider got an identity solution for application developers, right? Ours called AppID, Amazon Cognito, Auth0, you probably heard about them. Microsoft, they have Active Directory B2C, right? Okta, Ping Identity. There are tons of solutions for identity. They pretty much all of them do roughly the same, okay? To be honest, they do have some, crown jewels, but most of them do the same. But when you're picking your identity, well, before that, please pick a solution that will handle your user identity and access controls. Do not try to implement it yourself, okay? We don't have GDPR here in Texas, okay? But we'll probably have something in a couple of years, in a few years, right? California started to introduce rules similar to GDPR, General Data Protection Rules policies, right? If you store personal data of your users, you'll need a separate team, big team, right, just to manage that. Okay, it's not easy. Those services, because there is a lot of them, they're pretty cheap. Okay, so they are very cheap to use, to be honest, right? You're talking about 0.00 something cents per authentication or per user, right? And they do this job for you. So things like compliance, HIPAA, GDPR, SOC 2, PCI, ISO, all of that, right? You're storing PII, personal data. You need to, now you don't need to worry about that. So features that you want to have from those services, that's basically authentication and authorization, right? If they handle your user authentication for you, they need to be able to authenticate users to do second factor authentication, for example. You want those services to be based on open standards. Auth2, OpenID Connect, Scheme, SAML for more enterprisey flavors of that. So they need to be able to handle that. Most services do provide a lot of open source server and client SDKs for most popular programming, like Java SDK, Node SDK, Python SDK, Go SDK, etc. Right? Since most of those services are provided by different cloud vendors, cloud platforms, usually they also have integration with the runtime environment of that cloud platform. So if you have 50 microservices running on Amazon or an IBM, you don't need to instrument every single Microsoft with the SDK. You can just use their gateway approach and configure the authentication at the gateway instead of changing your code every time there is a minor configuration update that you need to do. So all the providers have that. User management, right? You might already have existing Active Directory or something similar that contains your users, some LDAP server, but in many cases, what we're seeing, at least with our customers, that's expensive to manage. That's not part of their core business. They want to move to cloud, and they're looking for a secure solution. Okay, so if that applies to you, those services handle the job perfectly. And since it's a user management available in cloud, they will provide you with default UIs. They will provide you with APIs. It will be configurable. They will send emails. Welcome to my application, which is fully customizable. So all of that is coming from the service. All of that is, trust me, those are the capabilities that you might want to use. And you want to have those services giving you some kind of a profile management. So in addition to standard user information, username, password, first name, last name, you're building applications, right? We're here talking about applications. The whole goal of this is to build applications. And you might have 10 different applications, and all of those applications are different. All of them need username and password and first name, last name. But let's take airline example for a second, right? A major airline might have application for passengers, like for end users, right? For pilots, for flight attendants, and for technicians. Obviously, those are not the same applications. So in application for end users, you might want to pick whether that user prefers aisle seat or a window seat or a kosher meal or whatever meal, right? This data is completely irrelevant for all other applications, right? Technicians do not need to know that. So why would you store it in your identity solution? No, that's part of the user profile. That's a preference of a particular user that helps to make your application much more appealing, much more personalized. So those identity solutions, they provide you with these capabilities. If you're looking at next generation of those identity capabilities, right, that's where when we're coming to multi-cloud. That's actually when it starting to become interesting. So Amazon got its own solution, IBM got its own solution, Microsoft got its own solution. So if you're building a multi-cloud application, now you need to learn all of these solutions. That's a lot of work, that's a lot of fragmentation, okay? So the world, the industry is moving in the direction of multi-cloud solution. Okay, and that's actually something that we've prototyped in open source. So if you just Google for it, you'll find it. Multi-Cloud Identity and Policy Manager. You'll literally find it in Google. It's available on GitHub and Docker Hub, right? So the idea here is it doesn't really matter where you run your applications, right? You can run them on, let's say, front end might run in IBM ecosystem, back end might run at any other cloud provider, or even on-prem, right? So the idea is you can use this entity called Policy Manager to basically manage access, identity and access policies everywhere. Okay, so this is a technical preview that we've released. It's open source, it's free, you're welcome to use it. It's not, I wouldn't say it's IBM specific, obviously not. Other cloud providers are also participating in this game. Moreover, the component that we use for this, Istio, anyone here familiar with Istio? That's actually a partnership between IBM, Google, Lyft, Red Hat. Microsoft is contributing a lot as well. Right, so that's a service mesh component that makes it possible. Okay, so this is very generic to any cloud provider. Let's go next. How do you protect data, right? So you've identified your users, okay, using SAML or OIDC, right? How do you protect the data? So users are in. They need to read data, update data, whatever, right? So first of all, store your data securely, okay? The moment you find a database or object storage at a cloud provider, this is not the end, right? Make sure that the data you store there is properly secured. So first of all, only use storage types that support data encryption, right? MySQL is an amazing database, amazingly easy to deploy anywhere, okay? But it doesn't have the data encryption available by default. So basically what it means, your attackers, they're not necessarily evil people from outside, right? They can be nice people from the inside, right? So if one of your operators is not that happy, there is nothing that prevents him from basically getting a database dump and publishing that on GitHub. Okay, so well, keep your operators happy, right? But always use storage types that supports data encryption. Basically, even if your operators with their root access and everything can get to the data, it's encrypted. There is absolutely nothing they can do with that data. Okay, so how do you encrypt the data in a way that no one can access the plain text data? Well, use key management services for the keys that you own. Every cloud provider provides a key management service today. Usually they're called KMS, Cloud Key Management System. right? So a generic name. And it can either provide you a key that the cloud provider generates, or you can create your own encryption key and upload it to the service, right? The latest trend in the industry is keep your own key. Not bring your own key to the cloud, but keep your own key on your premises, enterprise, and the cloud provider would actually go to you for encrypting, decrypting data. So even more secure. So use those services. All the key management services, they integrate with databases. All cloud providers provide kind of seamless integration. So basically, you're not just creating a SQL database or NoSQL documents. You're connecting your database with the key management service, and you're saying, this is the key I want to be used for managing that. My operators, they might have access to database. Why? Well, they might need to be able to do something. My operators have no access to the KMS. Okay, so they can get all the data, they cannot get the keys, right? So how can data be decrypted? Only when it's running in production environment and you have authentication that the request is actually coming from the real microservice in production environment. When you're picking a key management service, pick the one based on HSM. That's a hardware security module, right? And basically, it's much more secure. It's a piece of metal, right? That its only mission is to protect your keys, right? So, the way they're designed, they will destroy all the data before an attacker can gain access to that box, right? Data and rest encryption using bring your key, keep your own key. Runtime encryption using data shield and application encryption. So data shield, that's a relatively new technology. You can Google about it. The idea of data shield is encrypted containers. That's what I've mentioned a little bit previously. Even when your application runs, the runtime, right? The runtime is encrypted as well, right? So you also always have a virtualization layer, right? And the virtual machines or containers running on top of that layer. So there's an encryption going on. So if attacker gains access to your host machine and does memory dump, there's absolutely nothing they can read from there. It's all encrypted in runtime using hardware capabilities of your host machine. So, data shield, that's a relatively new technology, mostly coming from Intel, right? Partnership with Intel. It's pretty cool. Keep this in mind. If you're building application in cloud, I would imagine you wouldn't build your own cloud platform, your own Amazon or IBM cloud, right? Cloud providers should not have access to your data, right? The fact that you're using MySQL or CouchDB or whatever, Cassandra in cloud, doesn't imply that the operators of that cloud provider should be able to access your data. And key management systems, they actually help you to do that, okay? Gain visibility. So I will talk about few tools. Okay, we still got 15 minutes. Okay, so this is crucial, right? This is, in many cases, audit and activity logs. In many cases, this is a little bit underestimated, right? The importance of having this information, but this can save you in many, many times. Anytime, you've seen the list of companies who were breached, right? The big ones are there as well, right? Sony, PlayStation, name it. Everyone was breached once in a while. What will help you in this case is ability to understand what happened, okay? What will help you to run the proper root cause analysis is ability to understand what exactly happened. Because if you do not have that information, there's absolutely nothing you can do to prevent it from happening the next time. So audit and activity logs are crucial. We use the service, a third-party service called LogDNA, right? It's I would call it a startup company, right? They are amazing. We absolutely love them, the capabilities they provide, right? Track activities for security, audit, and debugging. So record developer actions. Developer created a database, record the activity, right? Someone deleted a table in a database, record that activity, right? This level, cloud platform level activities audit is usually provided by the platform itself, right? But in your applications, user ordered pizza, record this, right? I'm just using pizza example, right? User logged in or logged out or changed address or did anything in your application, record that activity, right? Storing data today is very cheap, incredibly cheap, but this might help you to be able to detect what happened. So record developer actions, developers are doing on the platform. User actions, how users are using your applications. Alert into actions. If you detect activity that should not happen, so for example, a particular user is trying to log in for 15 minutes, always supplying wrong password. Okay, so probably you should get notified about that. This means probably it's trying to brute force right, an account. So set up alerts, right, and those logging services, they do support that. Right, fix issues with intuitive search queries. So basically, you can query, if you use a proper audit service, you can query the information. You can download that event data, and when you're picking your service, CADF, right, that's the format, cloud audit data format, right? That's the format kind of most popular today, right? So if you want your data to be movable from one tool to another, right, maybe you use a different tool for deep log analysis, right? Try to find a tool that supports that, right? You'll have a huge list of logs and audit events, right? You don't need to keep all of them in clear text in that service. So once in a while, you can automate, and again, all cloud vendors support that. Offload that archive to some kind of cloud storage. You'll have a huge zip file, right, for, I don't know, once a week, okay? And it will cost you like a couple of dollars to store all of that, right? But you'll have logs. If you're talking about compliances like GDPR, HIPAA, SOC, etc., I think if I recall, HIPAA is the harshest. They require you to store logs and access and activity audit for 7 years. Okay, so keep that in mind. This is what our service looks like, right? It's a LogDNA. This is what, well, not IBM service, it's LogDNA. It's that third-party company that I mentioned. This is what it looks like. You have records. You can open any of those records, and you can see, activity-specific things like event time, event UID, the name, that's the email, of my good friend Robert, right? Number of cluster, and you can store any custom data that you want, right? So, and then you can, at any point in time, just query the data to understand what happened. Certificate management. We talked about key management, and keys are usually used for data protection. Certificates are also used for data protection. Mostly certificates are used for authentication. So probably everyone is using HTTPS, right? If anyone is still using HTTP, stop, right? The only reason to use HTTP is localhost. Okay, there is absolutely no reason to use HTTP outside of localhost. You can set up HTTPS on localhost as well. That will be even more secure, right? So, I've seen customers. I work a lot with different customers, and I've seen customers with huge Excel spreadsheets with 500 certificates being tracked. Okay, so expiration dates, who's the owner, what's the department. I mean, it works, but it's awful. Right now, you need to have a separate Excel expert to manage your certificates. No, every single platform provides a way to manage certificates. You can upload your certificates. Up to you to decide whether you want to include private keys or not. You can integrate those certificate management solutions with your runtimes. So if you're running virtual machines and exposing them through GLB, through load balancers, you can basically configure those load balancers to pull certificates directly from certificate management service. So this way, whenever certificate has expired, 30 days before, you'll get a notification. And those certificate management services, they even have a button, renew certificate in many cases, unless it's a certificate that you've uploaded manually. Okay, so do not manage those certificates on your own. Store private keys in key management solutions, right? Because it's HSM protected, hardware security module, very secure. Or if you don't trust that, keep that in a secret folder on your computer or whatever, right? Upload your certificates without private keys to certificate management solution and consume those certificates from there. There are hundreds of outages, known outages of different services, because someone forgot to renew the certificate. Okay, so happened to anyone here, right? Happens to the best of us. Okay, security posture services. That's also something, doing good on time. That's also something available in most cloud platforms today by cloud vendors. Essentially, you have a lot of security information. You have those logs, right? You have network threat protection. You have identity services that authenticates your users and deals with access control, right? There's so much data that you need a single place to view that data and to act on that data, right? So we have what we call Security Advisor. Amazon, they have Security Center, I think they call it. Microsoft. All the cloud providers have that, right? It's a centralized console, right, to basically understand what's your overall security posture on a cloud platform, right? It will, if you're using containers, it will scan your images for vulnerability, right? Who's here using containers and Docker and Kubernetes? Yay, great, great. Everyone should use that, right? Who's here ever tested all the layers of base images they're using in their containers? Probably no one, right? Do you even know what the base layer of the image that you use and what that base layer is based on, right? The lowest layer called scratch, because you can write from scratch in your Docker file, right? But then you have a bunch of different layers, right? So you're probably using Ubuntu image or some other Linux or Windows image, right? But you have no idea what's going on underneath that. Those tools, they will scan your image. They will get to the level of, you know what, your curl from the very base scratch image, Linux layer, is outdated. You need to fix that, right? Something like that. So it will tell you about all the vulnerabilities of your images. And the great part is if you're using standard base images, the vendors, they use something like this as well. So they're patching their base images whenever new vulnerability is discovered, right? Certificate is about to expire, you'll get notification here, right? There's a suspicious network activity. The most popular example is a microservice that is supposed to return, I don't know, a list of departments, right, for a bank, for example, for some reason serving 500 megabyte zip file. This should not happen, okay? This is not the behavior of that microservice, standard behavior, so you should get a notification. And that's a place where you can also centrally manage security, and what's the best part about it is you can extend that. So if you have your own security tools, Jenkins is not exactly a security tool, but it's an amazing tool to do stuff, do pretty much anything. So you can easily hook reporting from your Jenkins into this tool, and now you have a different tile or a dashboard or whatever, basically saying your code coverage has dropped, okay, something like that. So all those tools, they are extensible, and they give you an option of having a complete picture of your security posture. So who this whole thing is for, okay? Now, you have, depends on your company, you have different personas in your company, right? CIO, CISO, not everyone has those, depends on the size of the company, right? Business owner. Now, the shift left trend that's going on in recent years, basically saying developers, they're responsible for more than just developing code, right? The whole DevOps flow is about developers are also somewhat responsible for operations. You cannot decouple development and operation. The DevSecOps means, well, you cannot really decouple security from development. So developers, they don't care about security, and there's some other guy that just runs around and screams, oh my God, this is vulnerable, and developers don't care about that. This is not how it works in cloud when you're trying to build a proper secure solutions. So we're seeing this shift left trend, right? New roles are establishing. So DevOps developer persona, right? Basically, that's a persona that implements security protection and fixes, more focused on an operational side, even though it's fixes, it's code, right? It's not XML configurations. And there's this new concept of cloud security engineer or security focal. In our case, it's a developer on a team. It's engineer with exactly the same skills. But usually, on a team of 7 people, you can usually find someone who has more passion towards security. Okay, at least it works for us, right? They don't always know they have this passion, but we managed to convince them. Okay, so cloud does introduces new challenges, right? This whole shift left thing makes you're going to your developers and saying, hey guys, right? Now you need to worry about security as well, right? And they're like, but we don't know anything about security. And most classic legacy solution tools, they're not really a good fit for modern Kubernetes world and containerized world, right? They're more of a classic on-prem tools. There are tons of new tools provided by all the cloud vendors. You need to know about things that you should be concerned with, right? You need to understand that, yes, there are things that I should be concerned with, and there are solutions for all of them. So cloud requires continued proactive awareness of changes and new threats, right? So in cloud, if you're using containers, we're probably deploying, 10, 15, 20 times a day, right? Every time we deploy, we recycle probably about 200, 300 containers, something like that. Okay, so those containers then come and go, right? They're not, long-lived thing. So those are very ephemeral. The workloads change often. If you're following CI/CD process, right? I'm not saying about even production environment. In your development environment, we probably have a deployment and development environment once a minute. Okay, so things change frequently. And new vulnerabilities are discovered. So even if you prepare your application for the current most popular vulnerabilities, the new ones will be discovered all the time. So you need to be consistently, aware of what's going on. So we covered these, right? To wrap up for a couple of minutes, activities that I recommend you take. So first of all, restricting network access patterns, right? If you're using Kubernetes, segment your microservices using network policies. If you have 20 microservices, it doesn't mean that every single microservice needs to be able to talk to every single microservice. Define the patterns your microservices communicate, restrict all others patterns. If microservice A doesn't need to talk to microservice D, restrict that, okay? If you're using, same if you're using Kubernetes, Kubernetes provide a feature called Calico policies. That's more of a network level policies. So you can say only requests are coming from this particular external origin are trusted. Let's say from Akamai, right? From your web firewall, web application firewall, right? Requests that are not coming through that authorized source, they're not authorized. Protecting at the edge, that's the DDoS and WAF protection, that's crucial. Legacy firewalls for pure infrastructure, the service, and VMware workloads, right? The changes are usually much slower there and limited, so you still use firewalls. User access patterns, right? Doesn't matter which platform you use, you always have some kind of resource groups and user groups, right? Separate production, pre-production, test, development accounts for different user populations. All of your developers, they need access to development and probably to testing environment, right? Some developers need access to pre-production. A very little number of people need access to production, okay? The way we work is we have workflows. Whenever on-call person needs access to production, there is a process, right, of that person getting temporary access. Everything is logged. Every little thing that person does in production account, because all of our developers, we're DevOps, right? All of our developers are responsible for operations as well at some point, right? Everything is recorded, okay? Use platform-provided IAM, identity and access management, to limit access to platform resources. So configure identity federation groups and maps. Basically, if you already have some roles in your company, use those roles. Maybe it makes sense to use them on cloud, right? Limit access with tight ACLs, access control lists. So if someone doesn't need access, there's no reason for that person to have access, okay? Identify users' microservices, so use user authentication and application authentication with identity services. Before granting access, right, make sure the entity is authorized to get that access. Data protection patterns, we talked about that, right? Even inside your clusters, if you're using Kubernetes clusters, even microservices that live within your protected ecosystem still encrypt data, okay? Because this way, if someone hacks one of the microservices, they cannot get access to other microservices, right? Well, at least they cannot listen to data. Use certificate management solutions to make sure all the certificates up to date. Use service mesh, for example, Istio or Linkerd, or there are other options, but Istio is most popular by far. It provides you MTLS within your cluster relatively for free. For free from financial perspective, but yes, there's some implementation effort, right? Encrypt your database buckets with key management service. And the last slide for today is, I think that's less. Track all the activity, right? All cloud platforms allowed to do that. They have solutions for user activities as well. So, use these capabilities. That's it, right? I know we're exactly at 11 a.m. If you have any questions, I'm not leaving. Do I need to leave the room? They have another speaker. So I'm going to be here somewhere. Thank you.